Good morning, dear student. In previous lecture, we already discussed the C13 chemical shift value and H1 chemical shift value for the organometallic compound. So in today's lecture, we are very much interested to solving the example based on this C13 and H1 NMR spectral data. So if you consider the first example, so this is the example, that is this is the organometallic complex C5H5. Okay, C5H5, its hepticity is 5. C5H5, it is a molybdenum complex. The metal atom is molybdenum and CO by 3, and it is twice, bracket twice, it is a complex molybdenum organometallic complex. So C5H5MO CO by 3 twice, it will react with TDS. Okay, it will react with TDS. So what is this TDS? The structure is here, TDS, that is TDS is nothing but your tetramethyl tetramethyl thiouramide sulfide. So what is this TDS? It is tetramethyl thiouramide sulfide. Tetramethyl thiouramide sulfide. So this is your TDS, that is tetramethyl thiouramide sulfide. It is TDS. So this complex, that is C5H5MoCO by 3 twice, it will react with your TDS in refluxing with the organic solvent, gives the product. So this is the reactant, that is molybdenum complex is reactant. It will react with your TDS, the structure is given here, and it will gives the product, and the product having the following characteristics, that is H1NMR is given. So the product having these characteristics, first, that is H1NMR. What information we obtain from this H1NMR for this product? That it gives two singlet. So two singlet we get at delta 5.5, at delta 5.48 ppm, and its relative area is 5, and again we get another singlet at 3.1 delta, and its relative area is 6. Okay, so this information is obtained from this H1NMR for this product. Then second, then the IR band is also given. So if you take the spectra of this product, then we get two IR bands for the product at 1950 and at 1860 per centimeter. And one more characteristic is given, that is mass to charge ratio. Its mass spectrum is also recorded, and we get the molecular ion peak after elimination of single electron from this product. So if you consider its mass to charge ratio, it is 339, it is not 331. So mass to charge ratio is 339. Okay, its mass to charge ratio is 339. So this information is given, and they ask what is the structure of the product, what is the structure of the product. So with the help of this data, that is NMR, IR and mass, we find out the structure of the product. So how one can find out? So let us discuss it. So this is the example, that is the molybdenum complex. It will react with the react with your TDS, that is tetramethyl thiouramide sulfide. Its structure is here. Okay, tetramethyl thiouramide sulfide. By refluxing with organic solvent, it will gives two singlet at 5.48 ppm and 3.18 ppm with relative area 5 and 6. The strong IR bands at 1950 and 1860 per centimeter, and the mass spectrum, that is 339. Mass to charge ratio, that is 339 after elimination of a single valence electron from this complex, that is the product. Okay, from the product. So how one can find out the structure of the products? So let's discuss. uh, with the help of this information, we can easily find out the structure of the product. Okay, So let's discuss it. So if you consider the first one, that is the first point is given, that is the H1 NMR, H1 NMR singlet. So we get singlet at 5.4 delta value. Okay, so we get singlet at 5.48 delta value. What it suggests, or what it gives the information, that the eta 5 cp, okay, eta 5 cp, that is your C5H5 ligand, that is cyclopentadienyl ligand, is retained in the product. So what this singlet at 5.48 delta gives the information, that whatever the molybdenum and the eta 5 cp, okay, so the metal atom and the ligand, that is eta 5 cp, attached to this molybdenum is also remain as it is in the product. So this H1 NMR singlet at 5.48 delta suggest, it will suggest, it will suggest the retention, it will suggest the retention of C5H5 ligand, it will suggest the C5H5 ligands, okay, C5H5 ligands in the product, in the product, in the product. Okay, so this is the important point. So the first information we get, that is the singlet at 5.48 delta suggests the retention of C5H5 ligand in the product. Okay, and the second one, that is the singlet. So another singlet is often the singlet at 3.18 delta, the singlet at 3.18 delta is most likely. So what is the singlet which is often at 3.1 delta, it is due to, okay, is most likely due to the methyl group. Okay, so whatever the singlet at 3.18 delta is obtained, it is due to the methyl group originating from the TDS, originating from the TDS, from the TDS, because we already discussed the structure of this TDS, tetramethyl thiuramide sulfide. So it having 4 methyl group. So whatever the singlet at 3.1 delta is most likely due to the methyl group originating from the TDS, originating from the TDS. And if we see the ratio, the relative area is also given, the relative area is also given for this at 5.48 delta. The relative area is given, the relative area is 5, and for this 3.18 the relative area is 6, relative area is 6. So what it indicate, okay, the ratio, the relative area indicates the number of protons, the relative area indicates the number of proton. So the relative area is 5 is nothing but there is a total 5 protons, and the relative area 6 indicating there is a total 6 protons. So what it indicate, the 5:6 ratio of hydrogen. So we can say that the 5:6 ratio, so whatever the relative area is nothing but the number of protons. So if the relative area is 5, so the number of proton is 5. If the relative area is 6, the number of proton is 6. So the ratio, that is 5:6 ratio of hydrogen, suggest, so what it suggest a 1:2 ratio, a 1:2 ratio 1:2 ratio of 1:2 ratio of C5H5. Okay, so this is the singlet we get at 5.48 delta. It is due to the C5H5, and we get another singlet is due to the methyl group from the TDS. So the relative area is 5:6. So this 5:6 ratio of hydrogen suggests 1:2 ratio 1:2 ratio of C5H5 ligands C5H5 ligands to methyl group to methyl group to CH3 groups. So 1:2 ratio means if there is a 1 C5H5 ligand is present in the product, then there is a 2 methyl group is present in the product, because the ratio is 1:6. So the relative area is 5:6. So 5 means all these 5 protons are equivalent in this eta 5 C5H5. So we get a singlet, and we get the another singlet at 3.18 delta, but its relative area is 6. So what it indicates, there is a total 6 proton, indicating the 2 methyl group should be present in the product, and it is originating from the TDS. So this much information we obtain from the H1 NMR data, that is the singlet at 5.48 delta. We are very much familiar, whenever there is a pi cyclic system is there, so it will gives the value. Okay, it will gives the value between 4 to 7 ppm, between 4 to 7 ppm we already discussed. So whenever there is eta 5 C5H5, eta 6 C6H6, so it will uh, having the chemical shift value 4 to 7 ppm. So 5.48 indicate the presence of C5H5 ligands in the product, and the singlet at 3.18 indicate the methyl group. Okay, methyl group present in the product, and it is originating from the TDS. Okay, so this much information we get from the H1 NMR spectra. Let us discuss the next important point, that is the IR value is also given. The IR band is also given. So 2 IR band we get. So IR band. So 2 IR band we get. Okay, so at 1950 per centimeter and 1860 per centimeter, and we already discussed that whenever the IR band that is the frequency, that is 1850 per centimeter to 2120 per centimeter. So whenever the IR band which is obtained from this 1850 per centimeter to 2120 per centimeter, it indicates the presence of terminal carbonyl. Presence of terminal carbonyl. It indicates the presence of terminal carbonyl, and this value, it is due to the what? Okay, so it is closely related to this value. So it is lying in between this value. Therefore, it indicates the presence of terminal carbonyl, and we get 2 IR bands at 1950 and 1860. It indicates both these carbonyls are a terminal carbonyl. So carbonyls are terminal carbonyls, and 2 bands is observed, means there is a 2 carbonyl is present. So we get 2 IR bands. So it indicate there is a total 2 carbonyl is present. 2 carbonyl is present in your structure. 2 carbonyl is present in your structure. So 2 IR bands indicating 2 carbonyl is present in your product, and the value indicating the carbonyl which is present in your product is your terminal carbonyl. So you should keep in mind. Okay, the next one, that is the next important point is that, so if you consider, the next important point is that the mass spectrum is also given. Okay, so mass to charge ratio, the mass spectrum is also given, that is M by Z ratio is given after elimination of single electron from the product. Okay, so it gives molecular ion peaks. So its mass is given, that is 339. 339. Okay, so up to this we get this information, that is H1, NMR, then IR, and then mass. Okay, and if you find out, then what to do to find out the structure of the product. Okay, structure of the product. So at least you understand this information, that there is a molybdenum atom is there, 2 carbonyl is present, then 2 methyl group should be present, then 1 eta 5 C5 H5 is also present. So uh, if you consider the mass spectrum is given, and the mass spectrum, we can say that the mass spectrum make it possible to pin down. Okay, the mass spectrum make it possible to pin down the molecular formula. Pin down the molecular formula. Pin down the molecular formula. Okay, so the mass spectrum make it possible to pin down the molecular formula, subtracting the molecular fragments believed to be present from the total mass. So what we done, that is we subtract. So subtracting the molecular fragment, the molecular fragments subtracting the molecular fragments believed to be present from the total mass, so what we can perform, the mass spectrum is given, so what it indicate, the mass of the product is given. Okay, the m by z ratio is given, indicating the mass of the product. Okay, so the total mass of the product is 339. So keep in mind, after elimination of single electron, so we get the molecular ion peak, and its mass to charge ratio is 339, indicating the total mass of the product. So whatever the m by z, that is 339, is nothing but the total mass of the product. And then we subtract the molecular fragments believed to be present, that is we find out that with the help of this H1, we find out that there is a 1 eta 5 C5 H5 is present, then 2 methyl group is present, from IR 2 carbonyl is present. So we all, and then again from H1 NMR, we already discussed that 1 eta 5 CP, 2 methyl group, and 2 carbonyl is present, 1 metal ion is present. So these fragments, the molecular fragment believed to be present, we subtract from this whole mass, that is from 339. So we can write total mass is what? Total mass is how much? That is your 339. The total mass is given, the total mass of the product is given, that is 339. And if you consider the metal atom is molybdenum, so the mass of the molybdenum, so mass of molybdenum, so we subtract all these fragments which is believed to be present from this total mass. Okay, so the mass of molybdenum is 98, so we subtract from this 339. So we all these fragments are subtracted from 339. So mass of molybdenum is 98, so we subtract from this 339. Again, the mass of C5H5, the mass of C5H5 is equal to 65. The mass of C5H5, which is equal to 65, so we subtract from this 339. Okay, again the next one, that is mass of 2 carbonyl. So again, the mass of 2 carbonyl, the mass of 2 carbonyl, that is equal to 56, that is equal to 56. So I have to subtract. Okay, So this mass, that is the mass of molybdenum, mass of C5H5, and the mass of 2-carbonyl, it is subtracted from the total mass, and finally after subtracting we get the remaining mass, that is 120. So this is your remaining mass. This is your remaining mass. This is your remaining mass. So this much mass is remain in the product. Okay, and what is the fragment for this 120 mass? So we find out. Okay, so up to this the total mass we know, and then the mass of molybdenum, mass of C5H5, mass of 2-carbonyl. Okay, we already subtract from this 339 total mass, and we get the remaining mass, that is 120. Okay, so you should find out the fragment, the fragments from the TDS having the mass 120. So let us discuss. If you see the structure once again, that is N CH3 CH3 C double bond S and S S. Okay, then carbon having double bond S, N CH3 CH3. So this is your TDS. So if you find out, okay, if you find out the 120, so we require 120 fragments, and if you cut this molecule from the center, then each fragment is having the mass of 120. So if you find out the mass, that is there is a 2 sulfur, so for 2 sulfur, so we know that for sulfur having atomic number is 16, so total mass is 32. For 2 sulfur it is 64. So for 2 sulfur it is 64. Then if you consider there is a total 1 2 3 carbon is there, so for 3 carbon having mass is 12, so 12 into 3, it becomes 36. It becomes 36. Then there is a nitrogen is there, one nitrogen is there. For one nitrogen it is 14, and the remaining is 6 proton. Remaining is 6 protons, so it becomes 6. So if you find out there, 6 plus 14, 6 plus 14, so total 20, and then by you have to take 2, and then it is 6 plus 2 8, 8 and 1 9, and 9 plus 3 it is 120. So the fragment which is remain, it is this fragment, or it is this fragment. So half of the TDS is present in your product. So what the remaining mass indicate? The half fragment of this TDS is present in the complex. Okay, so we can write here the 120 is exactly 120 is exactly half mass of TDS. 120 is exactly half mass of TDS. Okay, and it corresponds to S2 CN CH3 by 2, S2CN CH3 by 2. Okay, S2CN CH3 by 2, that is dimethyl dithiocarbamide ligand. So this is your dithiocarbamide. Okay, dimethyl. So it is dimethyl. So what is its name? That is your dimethyl dithiocarbamate ligand. Okay, dimethyl dithiocarbamate ligand. And finally we get the product, that is the product having C5H5 is there, molybdenum is there, C5H5 is there, molybdenum is there, 2-carbonyl is there, and the fragment is that is your S2CN CH3 by twice is also there. And if you see the structure of this product, if you see the structure of this product, then it is like this. Molybdenum is there, it having one eta 5 cp is present, two carbonyl is present, okay, two carbonyl is present, and the two sulfurs from this dimethyl dithiocarbamate ligands, it will attach to this molybdenum, and here it is attached to this carbon, okay, it is attached to this carbon, and then the carbon it is attached to nitrogen, and it having CH3 group, CH3 group. So this is the structure of your product, this is the structure of your product. So with the help of this H1 NMR spectroscopy, we identify that there is a one eta 5 cp is present and two methyl group originating from the TDS. Then IR information gives that there is a two carbonyls present, and these carbonyls are terminal carbonyl. And the last one, that is mass spectrum, is very useful to solving this problem. That is the already the mass of this total product is given, that is 339. So we subtract this fragment, that is eta 5 cp, molybdenum, and 2CO from this whole mass, and the remaining mass is 120, and 120 is exactly half mass of the TDS, and it corresponds to dimethyl dithiocarbamate ligand. So we can easily find out the structure of the product. So in similar way, you have to solve different examples, okay, and in the next lecture we discuss the remaining points of this chapter. Thank you.